Hello doctor, I am Havinash Rao. So we are from group 11 section 1 and I'm gonna explain about our group case study. So now let's go through the introduction. Engineering statics uses Newtonian physics to design and analyze systems, structures and objects related to motion, deformation and failure. Along with that, we will also learn mathematical modeling and problem solving techniques which will later help us in our engineering career. As for the group assignment, we have been given task to analyze the mechanical stability of electrical pole subjected to specific force and determine the reaction at its fixed base. The problem involves a pole weighing 1000 Newton and two attached cables, each applying a force of 500 Newton. So the next is, for our case study, we have chosen chapter 3, which involves equilibrium. So there are two types of equilibrium. One is the static equilibrium where the rigid body is at rest and all of its forces acting on it are balanced. The second one is dynamic where the body is moving with a constant velocity without acceleration due to balanced force acting on it. But for our case study, we will look into rigid bodies in static equilibrium. So the objective for this case study is we can understand the exchange of forces and moments applying principle of static equilibrium to solve the problem. This report will cover the overall methodology, calculation and results leading to a complete understanding of problem's behavior.
Good day, doctor. My name is Harish, and I'm here about to present literature review. An overview of structural mechanics. Structural mechanics is one of the basic subjects in engineering and physics to that deals with forces in equilibrium with bodies. Many thanks to Leonard Euler and Joseph Lewis for igniting the idea to analyze forces and movements of structural systems. There are few things that I stated in structural mechanics, which is fundamental subject in engineering and physics, focus on focus on forces and equilibrium with bodies, and also the forces of the movements at the fixed supports. Second, the equilibrium principles. In structural analysis, is the most important idea. As per the Newton's first law, the equilibrium is said to exist when the total force of the total moment acting on a body are both equal to zero. The principle provides the foundation of solving problems of statically determined structures, for example, poles and beams under force from the connected cables. Key contributions in the field include statics by J. L. Merriam and L. K. Carriage. These textbooks also explains the process of breaking forces into their components and solving systems of equations for equilibrium. Third, force and movement for cables. Here I have stated few of it, which is role of cables in structural systems, horizontal and vertical force components, contribution to movements at fixed points, Irvine 1981, behavior of taut cables under loads, and effects on reactions and moments. Cables usually make up part of structural systems. Cable forces are also discussed with a focus on the differentiation of force into the horizontal and vertical components, as well as the moments. RY 1981 conducted studies that dealt with the behavior of taut cables under load, their effects and supports, reactions, and the moments. Relevant findings on that cable forces make large contribution to the moments at fixed points. In this problem, this is evident with the structure and the cable arrangements, which makes it easier to calculate forces and movement of the symmetry. As in second slide, I went to the fourth point, which is fixed base reactions. In fixed base reactions, the analysis of the reaction at the fixed bases is very important in civil engineering and mechanical engineering. The fixed supports have to withstand translation as well as the rotation forces that are exerted by the loads. Works by Hibbeler, Engineering Mechanics, Statics explain how and where the support structures are intended to resist forces of reaction, as well as movements. Furthermore, Timoshenko and Young's work on rigid body equilibrium has given analytical ways to findings, reactions, and fixed systems. Last but not least, application in electrical poles. Electric poles are real life examples of structures that experience loads from different directions. Varma ECAL 2016 have also done a research on structural stability of poles and highlighted the importance of the wind loads, cable forces, and self weight. Wind forces are not an issue in this problem, but the weight of the pole and forces resulting from the cables create moments that fixed supports must oppose. Thank you from me.
For the problem definition, we derive the question from real-world engineering scenarios. Electric poles are typically supported by cables to ensure stability and prevent collapse, especially during strong winds. In this case, the question is to determine the reactions at the fixed base of an electric pole, where both cables are subjected to a force of 500 Newton each. The angle of each cable is 30 degree, and the weight of the electric pole, which is 1000 Newton, is neglected for simplicity.
Now we'll be looking at the mathematical modeling for this project. So the first step is to identify the forces in horizontal and vertical components using the summation of forces, which is noted as Tx equals to 0 and Ty equals to 0. The next step is to identify the moment of the horizontal and vertical components, which is noted as m base x and m base y. So the last step is to apply the summation of moment about the base of the pole, which equals to m base equals to m base x minus m base y. So now we'll be looking at the results for our group project. This is based on the mathematical modeling that we've done earlier. So the first thing is to note that we did an assumption. So the weight of the pole, which equals to 1000 newtons, was not included in our calculation. This is to simplify our calculation and not make it a hassle. Next would be the given information. Firstly is the height of the cables from the pole, which is 9.5 meters, to the ground. Next will be the force exerted by each cable, which is 500 newtons. Third, we have the angles of the cables from the horizontal axis, which is 30 degrees. And lastly, we have the horizontal distance between ground anchors and the cables, which is 1.5 meters for each cable. Third, we'll be looking at the force components. Firstly, we have horizontal components per cable. After doing the summation of forces for the horizontal components, we found out that each cable has 433 newtons. For the vertical components of each cable, we found out that it is 250 newtons. So now the total horizontal force is times 2 as there's 2 cables, so it will be 866 newtons. Same goes for the vertical forces. Since there are 2 cables, it will be 500 newtons in total. And lastly, we'll be looking at the calculation for moment about the pole from the base. So we did an early assumption that the anti-clockwise moment will be in a positive and the clockwise moment will be in negative. That is why in our calculation for the summation of forces for the moment about the pole, we found out that the horizontal axis or the horizontal components is in positive and the vertical components are negative. And after we've done the summation of forces for moment about the pole from the base, we found out that the total moment is 7,477 Newton meters. Now we have the discussion for our project. So this is based on our results and mathematical modeling. So firstly, we analyze our results. The vertical reaction forces balance with the sum of vertical cables components, confirming that there is vertical stability. Next, the horizontal forces cancel out each other, ensuring that the horizontal components are in equilibrium. Third would be the moment at the pole base, which is 7,477 Newton meters, reflects forces required to maintain an upright stability. Horizontal components have a significant stabilizing impact. The vertical components, however, contribute only minimal as the pole is already fixed to the ground. Next would be the challenges faced. So one of the challenges would be to determine a suitable assumption. For our case, it would be to neglect the weight of the pole. Second would be to ensure that consistent dimension and force values are kept constant at all times for an accurate calculation. Third would be the accurate diagram analysis to interpret geometry and verify tension force angles. Next on will be the application. So first we have relevant pole structures such as communication towers and transmission supports. And then we have the importance of the symmetrical forces distribution, which ensures structural stability in pole structures. Lastly, we have suggested improvements. This includes the pole weight for realistic scenarios. That will be one of the improvement. Second would be to account for environmental or external factors such as wind factors. And third would be to assess the condition or the material of the property and deformation for structural resilience and analysis.
As a conclusion, this question helps us understand rigid body equilibrium in 3D by applying static principles to determine force and moments. Working together enhance our understanding through ideas sharing and collaboration, highlighting the practical application of theory in stabilizing real-world structures. That's all from us. Thank you.